How is everyone? Just like put a reaction in chat or yeah, or just say something. All right, so today we'll be doing normal SAT science as today is a science day. However, we're also going to be doing a bit of ACT science, and we're going to be doing a bit of SAT math as well because we don't have that many classes left, and I want to get a couple more topics in, so we have time to, I guess, space it out instead of rushing through them next class and the class after. So yeah, we're gonna do SAT/ACT because the stuff we're going to be doing today is in both. Although the ACT does emphasize it a bit more, while the SAT doesn't really contain this as much as the ACT. But yeah, let's just get into it. So yeah, angles, arc lengths, and trig functions. So what are angles? I'm pretty sure just about everyone has learned them by now. Algebra teaches you them, and yeah. So angles are the space between space usually measured in degrees between two intersecting lines or surfaces at or close to a point where they meet. And how are they tested at the SAT and the ACT? So the SAT and ACT use angles measured in either radians or degrees in problems with like arc lengths, trig functions, sector areas, and like general problems with triangles and circles. What are radians? So radians are an alternative, I guess, measurement instead of degrees, and they're usually used with circles. You could say a circle is pi radians, is pi radians in radius or stuff like that. And I guess we'll jump straight into, so how do we convert between degrees and radians? So at the beginning of the SAT math section, the following information is given about radians and degrees. So you have 360 degrees in a circle, and the number of radians of an arc in a circle is 2 pi. And due to that, that means 360 radians is equivalent to 2 pi radians, and 180 degrees is equal to a single pi radian. And you can set up a proportional relationship to convert between radians and degrees measurements. So you have the equation radian measure over pi equals to degree measure over 180 degrees. So this also means we can use radian measures to calculate arc lengths and sector areas, just like we can with degree measures. So you have central angle over 2 pi equals to arc length over circumference is the same as sector area over circle area. So I'm going to be assuming that most of you have done some form of like even if it isn't really in depth, but some form of trig, because again, this isn't really that emphasized on the SAT. You're not going to get that difficult of problems, but the ACT does include some of these. So yeah, how would you use special right triangles to find radian measures? So you have special right triangles and circles. So at the beginning of the SAT math section, the following information about special right triangles is provided. You have these two images. 1 second. Let me just get my drawing tool out. Oh, I forgot to plug in my. All right. You have these two in the beginning of the SAT math section, and those give you special right triangles. And these, I have a chart right here with the angle measures and their radian equivalents, which appear frequently in questions about circles and circle trigonometry. And like the table below shows the angles in special right triangles and their equivalent radian measures. And you have 30 degrees is pi over 6 in radians, 45 degrees is pi over 4, and 60 degrees is pi over 3. And the radian measures we'll see on the SAT are usually multiples of the ones shown above. Let's just clear this. So here's like, I guess, quick review for trig functions, really. So you have cosine and you have sine. So tangent is cosine over sine over cosine. Oh, I didn't write this on the slide, but here's a really good I guess way of remembering it. So the way I remember it is, so ka, toa. And that is for this section of my memorization. So you have oh, whoops. Why did it do? Why is it like that? Okay. It's for this section, not secant, of this. So you have so, which is opposite over hypotenuse, opposite over hypotenuse, ka, adjacent over hypotenuse. And you have toa, which is one sec, that toa, which is opposite over adjacent. And that's a way of remembering this. As for the rest of them, you have secant is 1 over cosine. Cotangent is cosine over sine, or 1 over tan. And cosecant is 1 over sine. And I guess another way of doing these for cotangent, secant, and cosecant is if you're given the I guess like the sides, instead of having to calculate what cosine and then sine is, and then figuring out cotangent and secant from that, you can do cotangent is equal to adjacent over opposite. Secant is hypotenuse over adjacent, and cosecant is hypotenuse over opposite. And if you can tell, most of these are, I guess, basically the flipped version of it. Like you have cotangent, you have opposite over adjacent. Tangent, you have opposite over adjacent. And I guess the inverse of it, cotangent, is adjacent over opposite. You have secant, which is the opposite of cosine. And again, cosine is adjacent over hypotenuse, while secant is hypotenuse over adjacent. And same thing with cosecant, which is sine's, I guess, inverse. You have sine is opposite over hypotenuse, while cosecant is hypotenuse over opposite. And to the right here, I have a triangle, which I guess gives you information about what would be considered the opposite, the adjacent, and the hypotenuse. The hypotenuse is always the longest side, while the adjacent is the side given to the side close to the angle given. If it's facing this way, if an angle is facing that way, the adjacent is the one right next to it. And opposite is the one opposite to the angle that's given. And then at the bottom right, I have the unit circle. So for the SAT, at least, you don't need to know the unit circle much at all. However, it is good to know, again, for later math. Calculus uses this. And yeah, I'm guessing stuff past calculus uses this as well. So I would say maybe take a picture of this or some other way of recording it. I'll wait here for a minute while you guys have the time to take a picture or record it somewhere or another. And here's the link for the sheets, which has all the slide links in there. One sec, let me just make this bigger for everyone if you need me to zoom it in. One sec. Actually, I don't believe that there is a way for me to make this bigger. Is there? No. All right, if you guys have recorded it some way or another, just like say it in the chat or I guess put some reaction so I know that you guys are done. Or rather, if you haven't recorded it yet and you're trying to find out a way to record it, or you're writing it down, just say in chat if you are, I guess, since it would be easier for the people who haven't recorded it to say it than rather than people who have. All right, since no one's responding, I will assume that everyone has recorded it. All right, so here is, I guess, an example of what the SAT might ask us. So on the test, we might be asked to figure out the radian measure of a central angle in a circle in the XY plane, such as the angle AOB in the figure below. And to do so, we'll have to draw a right triangle and look for the side length relationships in the special right triangles, as shown in the slide previous to the previous slide, so 2 slides ago. So yeah, you have a circle here with I guess point A, point B, and point O. And we're trying to find out the angle right here because we want A, O, B. And to do so, we draw a right triangle using the radius O and A as the hypotenuse. And since the vertex of the right triangle is the origin, the 2 legs of the right triangle have lengths equal to the X and Y coordinates of point A. Because if you draw it right here, then the distance between this right here is 2, because it's a straight vertical line down from A. And the distance, I guess, up right here is also 2, because again, you're going to point A. And since like the 2 legs of the right triangle have the same length, we can say that it is a 45, 45, 90 special right triangle, since the measure of angle AOB must be 45 degrees. Because again, we have you're basically guaranteed you have to have 90 degrees here because it is a vertical, I guess, intersection. And due to the special right angle rule, it's a 45, 45, 90. So I guess here's a problem for you guys to do. I'll give you guys 2 minutes to do this, and then I'll do it myself. And yeah, just put your answer in the chat after you finish, so I know that you've got it. And I can explain it to the people who haven't. Again, I will say it is probably useful if you go back here, because I do have some measurements, like pi over 6 is 30 degrees, which might be useful in this case. Again, just put your answer in the chat, both of them, if you figure them out, or I'll say I don't know how to, or like ask me to explain it, so I know that you don't know how to, I guess. I'll give you guys another minute, maybe 2. Excuse me. All right, does anyone need more time? Just say in the chat if you need more time or if I should start solving it. I will say some of you have got it right. I'd say maybe half of you got it right. The other half got it wrong. And I saw a couple people asking for an explanation. So I'm going to assume that no, you guys don't need any more time. So there's two ways of doing this. The first way is because we know that AOB, which means this angle right here, is pi over 6, which is the same thing as 30 degrees. Because again, it was in that graph I gave you 2 slides ago. So because we know, or 3 slides ago, because we know it's 30 degrees, and if you draw a line right here to make this a right triangle, this has to be 90, and therefore this last one has to be 60. We can say this is a special right triangle of which is a 30, 60, 90 right triangle. And because in a 30, 60, 90 triangle, the shorter, I guess, leg is going to be of length x. The longer leg is of length x times square root 3, and the hypotenuse is equal to 2x. And since we know that the coordinate point of A is 2 square root 3, we're gonna the length of the longer leg is 2 square root 3, basically meaning that you have 2 square root 3 as the length of this, and because of that, x, which is, I guess in this case, is 2, so the height of the shorter leg is 2. So we have I guess what is the y coordinate? The y coordinate is 2, because again the shorter leg is 2, since the 30-60-90 triangle says it has to be. And because we know the hypotenuse is 2x and x is equal to 2, then we could say 2 times 2 equals to 4. And if the hypotenuse is 4, then since we know the hypotenuse is the radius, it's like 1 point going from the center to somewhere else, that the radius of the circle is 4. Any questions? And do you guys want me to explain the other way of doing this? Anyone? All right. I'll explain the other way then. Also, if I do stutter a little bit, it's because I have a cold right now. And if I do speak a little bit unclearly, again, my nose is kind of stuffy today. So yeah. So the other way of doing this is so the other way of doing this is, since the x coordinate of the point A is equal to so it's like a little bit more complicated. So since the x coordinate of A is equal to r cosine of theta, so you have to solve for r first. So you have 2 squared 3 equals to r cosine pi over 6. And again, this is a lot more complicated. You just need to know that since we do know the point right here, and we know the x coordinate is that, we could say it's r cosine theta. And when we do, I guess, solve it out, pi over 6 is the same thing as square root 3 over 2. That's because the unit circle, if we go back to right here, the unit circle, pi over 6 is the same thing as 3 over 2 right there. All right, undo that, go back. right? So you have 2 squared 3 equals to r cosine pi 3 squared 3 over 2. 2 squared 3 equals to r cosine 3 squared 3 over 2. And then you divide it's not cosine. What am I saying cosine for? The cosine of pi over 6 is squared 3 over 2. Then you divide by 3 over 2. Why was I taking that long? You divide by square 3 over 2, which is the same thing as multiplying this by 2 over square root 3. So you have 2 over square root 3 times 2 square root 3 equals 2r. And when you multiply these out, when you multiply these out, you get 2 times 2, because remember, you have square root 3 in the bottom, you cancel out square root 3 in the top over here because you're multiplying them. You have 2 times 2 equals to 4, and that gives you r. Your radius equals to 4. And so because of that, and you know that y equals to r sine theta. So the formula for this in the beginning, when I did this, the formula for this is x. When you're given a point, it's x equals to r cosine of theta. Then when you're trying to figure out y, it's y equals to r sine of theta. So you have y equals to r sine theta, and you know r is 4, so you have y equals to 4 sine pi over 6, which is again you have 4 times 1/2, because sine of pi over 6, if we go back, sine of pi over 6 is 1/2. Is 1/2. And then because it's 1/2, you have y equals to 4 times 1/2, which is 2. Again, this is a lot more complicated than the first way I did it. You're required to know a little bit more knowledge than just using I guess deductive. I mean, so you would do this way if you knew about this way and not the special right triangles. However, I would say memorize your special right triangles and not have to like go through all of this instead. But yeah, that's how you get y equals to 2 here and radius equals to 4 through the other way. Any questions? Again, this is a little bit over what you need to know for yeah, this is like, you don't need to know this for the SAT really. However, there is another way of solving it. So there's not like ever one singular way of solving the problem. There's usually multiple, although some are going to be harder and more time consuming than others. But yeah, any questions? Again, for the people who are asking for today's slides, here is a link to a Google Sheets which contains all of the slide links. And yeah, so no questions? Right. So you have evaluation of models is like a question type in the SAT science ACT science section, and it counts for roughly 25 to 30% of the question types. And these questions ask you to like judge the validity of scientific information and like formulate conclusions and predictions based on that information, which like basically means you gather information in the article to support claims made in the question. So like if an article were to say, an article gives you some information, you're asked to say whether that information supports a claim made by the question. So I couldn't really find too much on how to explain it. So we're just going to do 2 practice ACT science tests, I guess. I guess not really even exchange for practice. So here's the link to it. So do you guys want to do it first and then do it with me since we do have more time today, or do you guys want to do it as I do it? Right, so we have one person for both. We have two people for do it. If no one else responds, I guess we'll just go with as I do it. Give you guys 30 seconds if anyone else wants to respond. All right, if not, all right. So, I guess we'll try something new today. Does anyone want to read out the first passage? I mean, paragraph, I guess, of the passage? Just raise your hand, I guess, or I can do it as well. Doesn't really matter. Right, no? So, passage 4. Suppose that this is passage 6. So suppose that 1 gram of material A, initially a liquid, is kept in a cylinder filled with a piston at a constant pressure of 1 atmosphere, which is ATM, I guess. Table 1 and figure 1, respectively, show how material A's volume and temperature vary over time as material A absorbs heat at a rate of 10 calories per second, cal over second. Table 2 gives the boiling points of liquid materials B through D at 1 atm. The heat absorbed refers to the amount of heat that is needed to turn 1 G of a liquid at its boiling point into a gas. So you have table 1, I guess, which gives you the time in seconds and the volume of material A. And then you're given a graph which tells that between 0 and 2 seconds, some gaseous material A is present, but there's not that much. And then you have table 2. So this is a really short, I guess, passage, to be honest. Usually they're a lot longer, I will say. However, if you do get a passage as short as this, that's always really good because you have more time to do the questions. So let's look at the questions, I guess. So based on figure 1, material A's temperature increased the fastest during which of the following intervals? So let's look at figure 1. During which of the following intervals? What is it asking? The temperature increased. All right. So from what we can tell, it increased between here to here. It stayed constant between this entire section and it increased again here to here. So I would say, do you guys want to do this question first and then tell me your answer? And then I'll tell you guys my answer after. Yeah, let's do that. Just put your answer in the chat first and then I will do it right after. And as always, if you don't know how to do it, just like put in the chat so I know that I guess you at least tried and you just didn't know how to do it. Right? Does anyone else need some time or should I just solve the question now? Again, if you don't know how to do it, just say that, could you please explain it or whatnot? And don't be afraid of getting it wrong. It really doesn't matter if you do get it wrong right now. Again, this is not the actual ACT. And getting it wrong just means that you have a chance to improve whatever you got wrong. And at least I can try explaining a reason for why you got it wrong. And why the answer I think is the best answer. All right. So for this question, I would say the time at which it improved the fastest would be from here to here. So 22 to 24 roughly. And let's go back and put it here. Does anyone have any questions why it's D? Because it's pretty easy to explain if you have a question. If not, we'll just move on to question 2. No questions? All right. Question 2. Based on the passage in table 1, what was the density of liquid material A? So I'll give you guys a minute to do this. Again, just put your answer in the chat. So I know you guys got it. And if you don't know how to do it, just say, could you please explain it? All right. So for this question, I'm going to look down at the path at table 1. What is the density? So I would say the answer to this one is probably F. Wait a sec, someone had a question. So for the person with the question, why are there less people meeting? I would say, so the reason for that is that this again is a free class. There's like no real, I guess, binding thing that holds people from skipping, because again, their parents didn't have to pay anything, and therefore it really doesn't affect them that much if they skip. So of course there's gonna be people not coming. And also this class has, believe it or not, we've had almost 18 weeks of this class running so far. And that's a lot of time. I mean, honestly, 60 people is pretty good considering that we've been doing these classes for almost 18 weeks now. So yeah, you're gonna expect there to be less people than at the start, because again, this is a free class, and this is a really long class too. And it is sort of a commitment, so you're gonna have less people attending every class anyways. And yeah, so for question 2, I would say the answer is F, because figure 1 shows that material A was in liquid phase from like time from like 0 to 2. And table 1 shows that material A was had like a volume of 1 cm during this time. And according to like the passage, the mass of material A was 1 g. So like while material A was liquid, the density was is just 1 g. It's 1 g over cm squared or cubed. Because when you're given that it's 1 g, and it's the volume of it is 1 cm squared while it's liquid, then the density of it while it's liquid is 1 g divided by 1 cm squared, cm cubed. So yeah, you have F as your answer. What about question 3? Let's put your answer in the chat. I'll read it out, I guess. So suppose 1 g of material D at negative 10 Celsius is heated at the rate of 10 calories per second and kept at 1 atm until all of the liquid is vaporized. Based on figure 1 and table 2, a plot of material D's temperature versus time would be best represented by which of the following graphs? So yeah, just like put your answer in the chat after you get it. And if you don't get it, just like say it so I know that you at least tried and I know that I can give the answer. Right, I'll give another minute. All right, so it's asking us to go look at table 2 and figure 1 and figure out I guess which plot of materials d temperature versus time would be best represented I guess by one of the following graphs. So we know that at table 2, temperature material D boils at 28 degrees. So the horizontal line has to be at 28 degrees. So if you look through here, the horizontal line, one sec, there. So the horizontal line right here has to be at 28 degrees, which this one is not, and not, neither is this one. So now you're between C and D. And again, if you go down to table 2, you know that the heat absorbed is 270 calories, but we also know that heating occurred at 10 calories per second, as it says right here. So you divide 270 by 10 to get 27 seconds, because calories over seconds divided by calories is just gives you seconds at the end of it. And now we have to look for which one has, I guess, a horizontal time of 27 seconds. And it looks like this one is too short, therefore the answer is C. Any questions? No? All right. Question 4. Table 1 and figure 1 best support which of the following hypotheses about the temperature and volume of material A. Note pressure is assumed to stay constant. So yeah, I'll give you guys a minute to do this one. Again, just put your answer in the chat after you get it. Are you asking for the link for the slides or the ACT practice test? Or not? All right. Here. Again, just put your answer in the chat after you get it, so I know that you've done it, or if you don't understand how to do it, just say, please explain. Do you mean G or H? Because C and D don't exist on this one. All right, so from what I see so far, G and H seem the most popular, seem to be the most popular answers, with I guess roughly 50-50 right now. Do you guys need another 30 seconds to answer it? All right. All right, still 50-50, even though 2 more people answered. All right. Okay, so at last second, it seemed 2 more people got it. So table 1 and figure 1. So we'll just go in order, I guess. Or so do you guys want to go through each of them and tell me telling you guys why it's not correct, or do you guys just want the right answer and me explaining why that's the right answer? Of course, if you guys want me to explain a specific one, I will explain that one. All right, it seems like some people want me to go through all of them. So E is not the best answer. Because material A was like a mixture of liquid and gas, like between 0 and 2 seconds. I mean, no, not between 0 to 2, from 2 seconds to 22 seconds, as you can see right here. Right here. And according to table 1, I believe it says like throughout like the entire time that it was constant there, the volume increased because it was only like 1 for a bit. As you can see right here, the volume increased between from 2 to 22, regardless of the fact that like the gas and the liquid and gas mixture stayed roughly the same. And according to like figure 1, the temperature of the mixture also remained constant. So it didn't really increase, therefore E can't be our answer. For F, again, same reasoning. That doesn't match with what I just said. And like it just remained constant. That's really all I can really say to that. G works because when the temperature of gaseous material A increased, its volume will increase because when it did become all gas, if you see right here, when it became all gas, which is between 22 to 24, the volume also increased as well. Therefore, I believe G is the right answer. And then for H, when the temperature of liquid material A increases, the volume will also increase. So that's wrong because of the fact that right here, if you look right here, the temperature did increase by 20 degrees. However, when we go to the volume at the top at table 1, the volume did not increase right here. It stayed the same. Therefore, G is our answer. Any questions? So the correct answer is G. All right, question 5. Suppose 1G samples of liquid materials A through D are just beginning to boil. If each of the liquids absorb heat at the rate of 10 cal per second while kept at 1 atm, which of the liquids will be the first to be completely turned into a gas? I'll give you guys a minute to do this. Again, just put your answer in the chat after you get it. All right, I'll give you guys another 30 seconds. Again, if you need more time, just say it. I'm always willing to wait a bit, I guess, before I move on. Although I will say most of you have got this question wrong. Maybe 1/4 of the people who answered got it right. All right, make that 1/5 of the people who answered it got it right. Or no, 2/5, 2/5. All right, do you guys need more time, or should I just explain what I think the answer is and why? All right. So the answer to this one is A, and almost all of you got that wrong, which I guess is kind of, I guess, knowable. So the reason for this is if you go right here and you look at the boiling points, so you have 13, 19, and 28, and you have the heat absorbed. And you know that I guess the total number of heat absorbed by A is let me think. Is no, yeah. So the reason, and then you know that it took what, 20 seconds for A to be converted from liquid to gas, and it was burning at 10 calories per second. Where'd it go? Where does it say 10 calories? Right here. You know it's burning at 10 calories per second. So you can assume that it absorbed what, 200 grams of 200 calories of heat, and its boiling point is also a lot lower. So it took A 20 seconds to boil. And if you divide all of these, 500 divided by 13. Wait. You know, it took it, yeah, no, it absorbed 200 calories of heat. What am I saying? It absorbed 200 calories of heat, which is lower than all of the heat absorbed by all of the other three, and therefore is the first one to burn into gas. I overcomplicated it after I got the answer. But yeah, the reason it is the first one to turn to gas is because it absorbs the least heat before turning into gas. Any questions? No? All right, let's see what I got. All right, 5 is correct, 4 is correct, 3, 2, 1. All right, looks like they're all correct. All right, back to these questions, back to the slides, I guess. So, does anyone have any questions about what we've done so far in today's class? If not, we'll just move on to practice problems. So here's the first one. I'll give you guys 2 minutes to do this one, and then I'll do I guess I'll just do it in front of you guys. Excuse me. Again, just put your answer in the chat after you get it. If you guys need more time, just say it, or if you guys got your answer, just put it in the chat. Though it looks like most of you who have gotten your answer put in the chat have got it right. All right, do you guys still need more time, or should I do the problem? Either way is fine with me. All right, so the way I did this problem is, since you're given that you have a triangle ABC and B is 90 degrees, so you could say that you're given a triangle ABC, and if this point is 90 degrees, this has to be B. So you have A, B, and C. And because of that, you know, A and C is the hypotenuse, height. And BC is 16, while AC is 20. So with the Pythagorean theorem, you get AC, wait. No, it's, wait, did they give us AC? No, they gave us AC. I'm just being dumb. 20. And then you know that AB, because of Pythagorean theorem, has to equal to square root of 20 squared minus 16 squared, which should give you 400 minus 256. So AB equals to square root of 200 or 400 minus 256, which is AB equals to square root 144, which is the same thing as 12. And since you know that triangle DEF is similar to triangle ABC, with like the vertex F and C corresponding, then the measure of angle F is the same thing as the measure of angle C. And therefore, you could say that sine of F equals to sine of C. Sine of C. And from the sidelines, you know that the sine of C is sine of C. Remember, sine is opposite of our hypotenuse. So you have C's opposite, which is 12, over hypotenuse, which is 20, which is equal to 3/5. And since you know that the sine of F is the same thing as sine of C, you can say that sine of F goes to 3/5, which is 0.6. Any questions? Again, if you have any questions at all, don't be afraid to just like raise your hand and ask it, or ask it in the chat. If not, I will erase this and we'll move on to the next question. So questions like this could be on the SAT. I wouldn't say that they're not at all. And although I would expect questions like this to be on the ACT for sure. Just SAT, I'm not 100% sure if it would be on every test. However, I would say it probably would be on at least some. In the few times I've taken the SAT, I've seen it once. At least that I can remember. I don't know. There could be more, or I could be thinking of a different one. But yeah, I'll give you guys 2 minutes to do this one, and then I'll do it myself. Again, after you get your answer, just put it in the chat so I know that you've got it, and I know if people got it right or wrong. Right? You guys still need more time, or would you guys like me to do it now? So I'm just gonna put my computer in charge. All right, should I start solving it now, or do you guys still need more time? Although it seems like most of you have got this, right? Right, another 30 seconds. Seems like people are still solving. All right, so for one of you, I'll say, although you guys probably got the right answer, the way you did it is probably wrong if you got that. All right, so it looks like most of you have got it. I guess got a answer, if not the right answer. So yeah, there's two ways of doing this. So if you know the fact that sine x, if you know the fact that sine x and cosine of 90 degrees minus x degrees is complementary, then you would know that this really is just this. It's just 4/5. Another way of doing this, if you just didn't know that rule, is to plot it out. Not even plot it out, to draw a triangle of it. So you have a triangle of which one side is 90, and you have that. So you have x. I'm just gonna put x right here, and you know that x is hypotenuse of opposite over hypotenuse, so 4/5. And you would yeah, so you know x, the hypotenuse is 4/5, is 4/5, and 90 minus x. So you know, okay, so I did this, I didn't explain this very well, but you have 180 degrees in a triangle, of which you subtract 90 because of this, and you have minus x because one of the angles has to be x. So you have 180 minus 90 minus x, which is really just equal to 90 minus x there as your remaining angle. So 90 minus x has to go here. This is 90 minus x. And remember, cosine is adjacent edge over hypotenuse. So you have 4 on the adjacent side, 5 hypotenuse, 4/5, which is 0.8. Although I'm kind of curious how some of you got your answers, especially you, Pavan. How'd you get 0.799999? Which of course in a graph in the actual SAT, I'm gonna guess you would have either rounded to the right answer and luckily got the right answer, but that is oddly close to what the answer is, yet weird. If you would like to explain, if not, then I guess we could just move on. Because I guess it's just weird how you probably would have gotten the right answer. I was just wondering how you got 0.79999 and so on. The answer is 0.8 or 4/5. 4/5. All right. So yeah, next question. Yeah, I'll give you guys 2 minutes to do this one, and then we'll go on to the next and I'll do it. Although I am gonna start moving a little bit faster because there's quite a lot of questions still, and yeah, I want to finish them before class ends. So I'll give you guys a minute per question, I guess, a minute and a half, and then I'll do them. This one is a lot easier because I just explained it in the other problem. I'm just making sure people understood it. All right, looks like everyone understood what I said in the previous problem, if they got this question. So as I said in the previous problem, when you have a sine of an angle here, that's the same thing as the cosine of an angle here. Because again, sine of something here is opposite for this guy, and hypotenuse is the same thing as adjacent for this guy, and hypotenuse for this guy. So the answer is 0.6. All right, any questions? No? All right. I'll give you guys a minute or 2 minutes to do this one. This one has radians in it, which I guess is kind of harder than the other ones. However, it shouldn't be too hard. After this one, we'll move on to questions straight from the SAT study guide from 2020. So I'm gonna guess all the questions will be literal questions from the SAT, since the College Board did make the study guide. And we're gonna be skipping a couple questions after this to get there, because I don't believe we'll have time to do everything. So yeah, after this question, we'll go on to, I guess, direct questions from the SAT study guide from 2020. All right, I'll give you guys another 30 seconds. All right, so for this question, the best way of solving this is distance formula. So, yeah, so distance formula, you have square root of square root of 3 squared plus 1 plus 1, which really is squared, but like plus 1, equals 2, which is the same thing as square root of 3 plus 1, which is equal to 4, squared 4, which is equal to 2. And you know that sine of A O B, I'm just gonna say sine is equal to 1/2, because you got 2 here and you have your 1 here. Because remember, 1 is right here. This is the 1 goes right here. And we just found out what this is. Or no, not that. We just found out what we just found out that with the distance formula it is 2. And therefore the angle of AOB has to be 30 degrees. 30 degrees. 1 second, let me just think about this real quick. How exactly did I solve this beforehand? So you use the distance formula, and then oh yeah, you're right. So now now that you know it's 30 degrees, you multiply it by pi over 180 to get pi over 6. Although this does use a little bit more knowledge than I guess what's really expected to know in the SAT. How did you guys do it? Was it a simpler way, or did you guys do something similar? Oh yeah, right. The other way of doing this, I did a really long way of doing this. Is to recognize that this is a 30, 60, 90 triangle. And because of that, you know that since the long, I guess, since the long bottom angle is square root 3, and the other side length is 1, then therefore it has to be 6 for the hypotenuse, because remember 2x, x, and squared x squared 3. So yeah, yeah, that works. And then you have Wait, this is 2. And yeah, that works out. Yep. All right, we're going to skip all of these and go on to questions from the study guide. So yeah, I'll give you guys 2 minutes to do this one. The answer to the previous problem was 6. Again, if you guys didn't know, I put all of the answers to every question at the bottom of each slide. If you guys want to double check. Also, I did show the answer for this one, but it looks like most of you who did answer it before I showed it to you already got it right. Because again, it is really similar to one of the previous questions we did. But yeah, the answer to this one is 0.263. And the reason for that is because the definition of cosine of r is rq over rp, and the cosine of z is zy over zx, and since they're similar, then the ratios are going to be similar, because again, the ratios are similar when ratios for everything is proportional when the triangles are similar. So yeah, the ratios will be the same for both of them. So 0.263. Here's the next one. All right, looks like people who did answer have got it right. Do you guys need more time, or should I just answer it? Or do you guys want to move on? Does anyone want an explanation for this problem, since it looks like everyone who's answered has got it right? Yeah, it looks like everybody who's answered it has got it right. Do you guys want an explanation, or move on to the next question? All right, we have 1 for move on. All right, we're moving on then. And if we do get through all these example questions, we can go back to the questions I skipped and do those again. Or no, never mind. Someone wanted me to explain the problem. All right, so first thing we can do is we could set C, not the letter C, not the answer choice C. We'll set the variable C equal to the point -2, comma 0. So you have another point here. We're going to pretend it exists, and we're going to draw a line to make it a right triangle. If I can draw a good one. And so with like both of the legs at length √2 and √2, because B is √2 up and it's √2 over. And because of that, we know, since the two, I guess, leg lengths are similar, we know it's a 45, 90 triangle. And therefore, COB, so COB, which is this angle right here, has to be equal to 45, and angle AOB OB, which is complementary and it has to add up to 180. So 180 minus 45 equals to 135 degrees for angle AOB, angle AOB there. And therefore, when you multiply 135 degrees times 2 pi over 360, which is a way of getting the radian version of it, you should get 3 pi over 4, which is, in fact, the letter C. Any questions? Jeevan, you still have a question or? No? All right. I'll give you guys a minute to do this one and then I'll do it myself. I think I put a lot of the same type of questions in this one. I didn't mean to do that on purpose. I guess it just came out that way. Seems like everyone who's answered it has got it right. Does anyone want me to explain it? Right, looks like some people have actually got that. Some people got that wrong. So I'll explain it then. So for this question, so the complementary angle relationship for like sine and cosine works. It implies that sine of x equals to cosine of k of minus x, right? And this is true if k equals to 90 degrees. And since 90 degrees is the same thing as 90 times 2 pi over 360, that is pi over 2 radians, and therefore the answer is C. Any questions? No? All right. I believe that's the last of the ones for okay, yep. Let's go back to the ones we skipped then. We'll do one more. For anyone who's opened up the slides, which question do you guys want me to do the most? We'll do that one, and then that will be it for class today. Is there like a specific one anyone wants me to do, or should we just go with this one? Again, just put in the chat if you want to do a specific one or just this one. All right, looks like it's just this one then. All right. Put your answer in the chat after you finish, and then I'll go over it. All right, I guess I'll do this question now. So since a complete rotation around a circle is 2 pi or 360 degrees, but we don't care about that right now. It's 2 pi, right? And AOB has a measure of 5 pi over 4. Then we could say it's 5 pi over 4 of 2 pi, which when you divide, when you multiply the 4 down here, because division over division multiply, you get 5 pi over 8 pi. When you cancel out the pi's, you get 5 over 8. 5 over 8, I guess, of the entire circle. The answer is 5 over 8. Any questions? No? All right. I guess that's it for today. I guess next class, just review math concepts you're uncomfortable with again. We'll be doing volume word problems, right angle word problems, incongruence and similarity with like geometry. Some stuff that we did today, as well as just like some extra stuff for volume and right triangle stuff. And yeah, that's really it. That's it for class today.